Hello and welcome to another lesson on GCSE physics. Today's learning intention is to describe the particles in solids, liquids and gases. This lesson builds on some of the work that you will have done in years 7 and 8. For the Do It Now task, I would like to simply tell me what does this diagram represent, answer the question and then check your answer below. So this diagram represents the particles in a solid. Representing substance in this way is called the kinetic theory model, and obviously we're going to be representing solids, liquids and gases today using kinetic theory model. Today's success criteria is to be able to draw the particle diagrams for solids, liquids and gases using the kinetic theory model. We're going to consider what the limitations of the kinetic theory model are, and we're going to identify each change of state. So, what I would like to do now then, we've seen that this is the diagram that represents the particles in a solid using kinetic theory. I want you to now think what are the limitations of representing a solid in this way, please. Pause the video, write down your answers and then play the video to check them. So, the limitations of the kinetic theory model showing how the particles are arranged in a solid in this way are as follows. Atoms actually aren't solid spheres as this diagram would suggest. We've represented the atoms or the particles as being circles, in this case meaning that they're meant to be solid spheres, but that isn't what the shape of atoms actually is. They're actually much more complicated. Also, this does not show the forces between the particles, and obviously there's going to be strong attractive forces between the particles in a solid. And finally, it is only a two-dimensional representation, and obviously solids are actually 3D. Okay, next task then. What would be similar if this was the diagram for a liquid, and what would be different? I want you to pause the video, have a go at answering that question please, and then press play again to check your answer. So the similarities for a solid are that the particles would be the same size. Although obviously there's going to be some differences, the way you draw the individual particles, you would draw them all to be the same size. However, the particles would instead have an irregular arrangement. An irregular arrangement basically means instead of being in nice neat rows and columns like they are for a solid, instead their arrangement will be much more irregular. Essentially, irregular is the word used on the mark scheme for the GCSE exams. Okay, what I would like to do now for me folks is have a go at drawing the solid, a liquid and a gas using the kinetic theory model please. Pause the video and have a go at that task please. So the diagrams then that you would have drawn, we've already seen what a solid looks like. We've got the particles in nice neat ordered rows or in a regular arrangement. For a liquid, we've got the particles still touching each other, but instead of being in nice neat rows, they have a much more irregular arrangement as shown there. One of the things that I do notice when I see students work on this is there's this temptation to kind of draw the particles really, really small, and that means you've got to draw a lot of circles. That's not the case. You can draw them nice and big like I have done here for you on the board, and then that means you've got to draw fewer particles. And then for the particles in a gas, the particles are much further apart from each other and the particles should not be touching each other. To labour that point of them not touching each other, I've only actually drawn 3 particles here in the gas to signify that there's large distances between them. Okay, let's now go over some details about solids, liquids and gases then. So, as we know, solids are very, very difficult to compress. If you get a brick or something like that and you apply a force to it, it's probably not going to change shape. So we can say that solids are hard to compress and they have fixed shapes. Now then we can look at them solids on a particle level. The particles in a solid are not able to move freely. They do stay in the same place, but they vibrate about those fixed positions. The particles have a regular arrangement in neat ordered rows and columns, and the particles will only have a small amount of energy, which is why they vibrate. And then an explanation as to the above 2 points are that there are strong forces of attraction between the particles. That is why they are close together and touching, but that force will actually become repulsive if the particles get too close. In other words, once they're touching each other, if you try and push them even closer together, then those forces become repulsive and push away from each other. Liquids. Liquids will take the shape of the container that they are in, and they also are very hard to compress. We can actually use the words incompressible if you wanted to describe a liquid. The particles in a liquid have an irregular arrangement. They are able to move freely, and they will change direction quite often when they collide with other particles in the liquid. And there is some forces of attraction between the particles, but the forces of attraction are not as strong as they are in a solid. Gases. Gases again take the shape of a container, but unlike liquids, gases are easy to compress. The particles move in random directions and they move at a range of speeds. Not all the particles in a gas have got the same speed. The particles in a gas have lots of energy and they don't change direction very often because they don't collide with other particles very often. The forces of attraction between the particles in a gas are negligible. The word negligible means very small or hardly noticeable. Now you will have studied at Key Stage 3 in Years 7 and 8 the idea that a solid can turn into a liquid and a liquid can turn into a gas, etc. We call that a change of state. Now the different changes of state have got different names. So the first one that we'll talk about, a solid going to a liquid, that is an example of melting. However, if a liquid goes back into a solid, we refer to that as being freezing. Now a liquid can turn into a gas by one of two processes, either evaporation or boiling. We will look at the difference between evaporation or boiling in a future lesson. Now a gas can then turn back into a liquid, or it can turn back into a solid straight away by a process called condensation. And then finally, a solid can go straight to a gas without ever being a liquid in a process called sublimation. Okay, task for you to do. We've got 4 changes of state here on the board. Clothes drying on a washing line, snow turning into liquid water, making ice cubes, and the shower steaming up. I want you to tell me, please, what each of these changes of state are. Pause the video to have a go at the questions and then press play again and we will go over the answers. So question 1, clothes drying on the washing line, that is an example of evaporation. I wouldn't accept boiling as an answer because in the situation here the water never reaches 100 degrees and so it doesn't boil, it is evaporation that is happening there. Question number 2, snow turning into liquid water, that is an example of melting. Question number 3, making ice cubes, that is an example of freezing. And number 4, a shower steaming up, which is a gas turning into a liquid, that is an example of condensation. Okay, I would like you to have a go at an exam question now for me, please. Have a go at the whole question, pause the video whilst you're doing so, and then check your answers. So it's question 3 from the exam paper, and it says figure 3 shows a model of the particles in a liquid. And it says give one similarity and one difference you would see in figure 3 if it showed the same substance as a gas. Well, the similarity is that the particles would all be the same size. The key difference is that the particles will be much further apart. 3.2. Describe 2 limitations of the model shown in figure 3. So the limitations of this are that it is only in 2 dimensions and obviously a real liquid is in 3 dimensions. And then the second mark you can have is for pointing out that atoms are not actually solid spheres, they should have a more complex shape. I would also accept as well as an alternative mark that it doesn't show the forces between the particles. Then finally, question 3.3, it says explain why substances have different melting points. The first mark is for saying they have different sized forces between the particles, and the second mark is for saying and so different amounts of energy are needed to overcome these forces.